In the previous lecture, I explained 7 different properties of impulse signal. Now in this lecture, we will try to understand the remaining properties. The first property in this lecture and the 8th property till now is based on multiplication. The 8th property is based on multiplication. In this property, we will see what will be the result when we multiply a signal by impulse signal. Let's say there is signal xt and we multiply this signal by delta t minus t1. So an impulse signal is multiplied to a signal xt, and we can obtain this impulse signal by shifting the unit impulse signal, and the amount by which we are shifting is t1. I will first write down the result of this multiplication, then we will try to understand how we have obtained the result. The result is x t1, the amount by which we are performing the shifting, multiplied by delta t minus t1. So there is no change in the impulse signal. It is delta t minus t1 on the left hand side and also delta t minus t1 on the right hand side, but the original signal, which was xt, is now changed to xt1. Now let's try to understand how we have obtained this result. For this, I will consider signal xt having the waveform like this, and we already know how the waveform of signal delta t minus t1 will look. Delta t minus t1, let's say this is t1, so we have the impulse at t1 and the weight of the impulse is 1, and we are multiplying the two signals, and here I will plot the waveform of the resultant signal. The resultant signal is x t multiplied by delta t minus t1. So till now everything is clear. Now let's try to understand how we have obtained this result. If you see delta t minus t1, you will find from minus infinity to t1 the value of signal is 0. So when you multiply delta t minus t1 to signal xt from minus infinity to t1, you will get 0, because 0 multiplied by these values will result into 0. Now from t1 to infinity, again delta t minus t1 is equal to 0. So from t1 to infinity, we are going to get xt multiplied by delta t minus t1 as 0, because 0 multiplied by all these values is equal to 0. Now in this signal, let's locate t1 first. This is t1, and at t1, this is the value of signal xt. Let's call it a1. So signal xt1 is equal to a1, which is a constant value. Now when t is equal to t1, delta t minus t1 is infinity, but in impulse signals we do not write infinity, we write the area or the weight of the impulse signal, and in this case weight is equal to 1. So when t is equal to t1, signal xt is a1 and delta t minus t1 is having weight equal to 1. So what we are going to get in the resultant signal, we will get an impulse. We will definitely get an impulse, because whatever be the value of signal multiplied by infinity, we are going to get infinity. But remember, we represent the area here. We write down the area here. This is how the notation of the unit impulse signal is defined. So a1 will be multiplied to the area. So here we have a1. So the resultant signal is an impulse signal, and it is delta t minus t1 with the weight equal to a1, and instead of writing a1, we can also write xt1. So let's write xt1 instead of a1 to generalize the result, and if you compare this, you will find it is same as the right hand side. So I think you now understand how the multiplication property is working, and we will try to solve 2 questions based on this, and it will clear all your doubts. In the first example, there is signal yt, and it is equal to twice of t square multiplied to delta t minus 3. So this signal here, twice of t square is xt, and delta t minus 3 is the impulse, and we already know what will happen to the final signal. that is after multiplying these two signals. In place of t we will write 3, so we have 3 square multiplied to delta t minus 3, and we have this result by following the multiplication property. T1 in this case is equal to 3, and this t we have to replace by t1, so we have replaced this t by 3, so we have 18 delta t minus 3. So after multiplying we have this signal. The signal is impulse signal with weight equal to 18. So this is all you need to do in the first problem. Now let's move to the second problem. In this signal yt is equal to cos 4t multiplied to delta 2t minus pi. This question is little bit tricky as compared to the first question, but it is easy if you know all the properties. Now before using the property of multiplication, we will first use the property of time scaling, because here we have scaled the time by multiplying 2. So in next step we have cos 4t multiplied to delta. I will take 2 common, so inside the bracket we have t minus pi by 2. Then we have cos 4t multiplied to 1 by mod 2 delta t minus pi by 2, and we have this result by following the property of time scaling. Mod 2 is equal to 2, so we have cos 4t multiplied to 1 by 2 delta t minus pi by 2. So we have multiplied this impulse to cos 4t, and instead of writing t we will write pi by 2, because here t1, the amount by which we have performed the shifting, is pi by 2. So in next step we have cos 4 inside the bracket pi by 2. The impulse will remain same, 1 by 2 delta t minus pi by 2. Now we will simplify cos 4 pi by 2. Cos 4 pi by 2 is equal to cos 2 pi, and cos 2 pi is equal to 1. So 1 multiplied by 1 by 2 delta t minus pi by 2 is 1 by 2 delta t minus pi by 2. So this is the answer of the second problem. Signal yt after multiplication is equal to an impulse with the shifting equal to pi by 2, and the shifting is towards the right, and 1 by 2 is the weight or strength of the signal, and this is also the area of the signal. Now let's discuss the next property, the ninth property. In the ninth property, signal xt is multiplied to delta t minus t1, and we are interested in calculating the area of this signal. So we will integrate this multiplication from minus infinity to infinity with respect to time. I will first write down the result here. The result is simply xt1, and as we have seen, xt1 is going to be constant. The area is definitely a constant, it is not varying. So this result is also an important result. Whenever you multiply a signal by an impulse in which there is shifting by t1, the area of this signal is going to be xt1. Now let's try to prove this. We will use the property number 8 to prove this. Xt multiplied with delta t minus t1 is equal to xt1 delta t minus t1 according to property number 8. So I can write xt1 multiplied to delta t minus t1, and as we are integrating with time, I will write dt, and we are integrating from minus infinity to infinity. xt1 is a constant. This xt1 is a constant, so I will take it out of the integration. So we have xt1 integration minus infinity to infinity delta t minus t1 dt, and as this signal is obtained by performing the time shifting on the unit impulse signal, the total area is going to be 1. So this integration will give us result equal to 1. So we are having xt1 as the final result, and from here we have written this property. It is an important property. We will use it while solving the questions. Now let's try to solve two examples based on this property. In the first example, the integration is given, and it is integration 2t square multiplied with delta t minus 4 dt, and the range of integration is from minus 2 to 2. Now you need to tell me the value of this integration. The answer is very simple but little bit tricky. Whenever you have the unit impulse signal or any impulse signal, always check the limit. Here limit is from minus 2 to 2, but here the impulse signal is having the shifting of 4 towards the right. So if you draw the impulse signal here, delta t minus 4, you will have the waveform like this. This is 4, but the range of the limit is from minus 2 to 2. So you can see in the range the impulse of the signal is not included. So the result of the integration is going to be 0. The result of the integration is 0, and this is the answer. Now why the result of integration is 0? Because by using the property number 8, you will have 2 4 square. 2 4 square is a constant, so we will take out the constant and we are left with integration delta t minus 4 from minus 2 to 2. But from minus 2 to 2, delta t minus 4 is 0, and integration of 0 is 0. So when you multiply 0 to the constant we have taken out, the final result will be 0. I hope you understand how we have solved the first problem. Now let's solve the second problem. In the second problem, the integration is equal to integration minus 10 to 10, and the signal xt is 2t square again, and the impulse is delta t minus 4. So we have the same integration as the first problem, but there is difference in the upper and lower limits. Here we have minus 10 to 10. So when you have the limits here minus 10 to 10, you can see the impulse is included in this range. Now we can easily have our answer. The answer by using the 8th and 9th property is equal to xt1. t1 is equal to 4, and xt1 means 2 t1 square, or we can write 2 4 square is equal to 32. So 32 is the answer of the second question, and in this way we have clear understanding of property number 9. Now we will discuss the next property, which is property number 10. In the property number 10, there is integration from minus infinity to infinity xt multiplied to the nth derivative of delta t minus t1, and it is equal to minus 1 raised to power n, the nth derivative of signal xt itself, where t is equal to t1. So this is the 10th property, and in this property there is one condition. This property is only applicable when signal xt, when t is infinity, is equal to 0 or finite. So when you put t equal to infinity in signal xt, it should be 0 or it should be some finite value. When this condition is true, we can use this property, and now we will solve one question based on this property. In this question, the integration I is given, and it is integration minus infinity to infinity cos pi t multiplied with the second derivative of delta t minus 1. And in this case we will first try to find out if this condition is satisfied or not, and for this we will put t equal to infinity in signal xt. Cos pi t is signal xt, and you already know cos pi t or any cos function lies between minus 1 and 1. So definitely when t is infinity, this cos pi t will produce some finite value. It could also be equal to 0, but it will not be infinite. So we have this condition satisfied for this question, and now we will use the property directly. and from property we have minus 1 raised to power n. Here n is equal to 2, the second order derivative. So here we will have 2 multiplied to the second order derivative of signal xt itself. Signal xt is cos pi t. So here we will have cos pi t, and t should be equal to t1. t1 is equal to 1, so t should be equal to 1. Now we can easily simplify this. Minus 1 raised to power 2 is equal to 1, and we need to find out the second derivative of cos pi t. Simply differentiate cos pi t 2 times and you will have minus pi square cos pi t, but we need to put t equal to 1 here. So when we put t equal to 1, we will have minus pi square multiplied to minus 1, because cos pi is equal to minus 1 and we were already having minus pi square. So finally we are going to get pi square. So this is the answer, and you can clearly see how easy it is to get the answer if you know the properties. If you have this question and you try to solve it without using the properties, you could not have the answer in 3 steps. So this is all for the properties, but there is one more property which is not that important, but I will mention it here, the property number 11. When you differentiate the unit impulse signal, this means the first derivative of unit impulse signal, it is known as doublet function. And this doublet function is an odd signal. So this is all for the property number 11. You should know what is doublet function. Who knows, it will appear in your examination. So if you have any doubt regarding this lecture or even the last lecture, you may ask in the comment section. In the next lecture we will solve one question in which we will use the properties we have learned till now.